All right. So about this logic gates. So logic gates, you know very well. There are basically three types of logic gates: AND gate, OR gate, NOR gate, and then apart from that, AND gate, OR gate, and NOT gate. Apart from that, there are NOR gate and NAND gate, and then there are XOR gate and XNOR gate, whatever. So those are not there in the NCRT, and you are quite comfortable masters actually in all those making truth tables, different kinds for different gates. And here I am just going to tell you how do we make those gates using those diodes and transistors that we have discussed so far. Okay, so a positive input means a higher voltage as so we know that there is like a on and off kind of thing, 0 and 1. These are the two input voltages. So for example, if the input is 0 volt, we say that the input is 0, and if the input is, let's say for example, a high voltage like 5 volt, then we say that the input is 1. Similarly on the output side also, if the output voltage is 0 volt, we say that the output is 0, and when the output voltage is 5 volt, we say that the output is 1. So high voltage means 1, low voltage means 0. So how do we make those gates using those diodes here? So this is a very simple thing. This is a OR gate here. These are the two inputs. All right, so let's start. As we know that what, although this is taken to be the output, but this we know that the output is taken across this and the uh, earthing. So everything is taken with respect to earthing. In fact, this input is also taken with respect to earthing, and this input is also taken with respect to earthing. Okay, so earthing is also always taken as the reference to be 0. That means if the input is 0, that means this is 0 volt supply, this is 0 volt supply. Okay, so the four kind of possibilities here for the inputs is here we have supply 0 volt, 0 volt, or here 5 volt, here 0 volt, or here 5 volt, here 0 volt, or both can be 5 volts, which are all these four things which are shown here. So, and this is where we take the output. This is the output voltage. Whatever is the voltage of this point is taken to be the output voltage. So what if we supply 0 volt, 0 volt here, then no current flows here, and if no current flows here, this remains 0, because no current flows means IR is equal to 0, and if IR is equal to 0, then this potential difference is 0, which means this potential and this potential are same, and this potential is earth potential, which is 0 potential, so this potential also is 0, output is 0. So 0 0 means 0. So if you make a like this truth table kind of thing, 0 0 means 0. Now if we come to here, for example, if we supply 5 volt, so if we supply 5 volt, we can say that the current can flow through this. So there is a potential difference. Remember that all these voltages, for example 5 volt here, are supplied with respect to this earthing. So between this there is a 5 volt potential difference, which means this diode is a forward bias, and when this diode is forward biased, there will be current here, and this current will go like this. This is unbiased, so nothing will come here. And anyway, when this becomes forward biased, we can say that current will flow through this, and the forward bias potential drop across the diode, ideal diode, is negligible. For example, if this is 5 volt, and even if we assume that there is a small 0.6 to 0.7 potential drop across the diode in the forward bias condition, this will still come out to be around 4.2 to 4.3 volt, which is quite a high voltage. So this voltage will be high. Or if we assume the ideal diode condition, then in the ideal diode supplies current without any potential drop across it, so no potential drop here. So whatever is 5 volt here, the same is the 5 volt, 5 volt, 5 volt, so output becomes 5 volt. So if this is 5 volt, which is positive, which means 1 0, then the output is also 5 volt, which is again a high output or 1 output. You can say that there is a current. So if this is 0 volt, because of this reference earthing, then what is the potential here? IR, because the potential drop across the resistor is IR, so IR minus 0 is IR potential drop. Now what if we, instead of supplying 5 volt here, if we supply 5 volt here, just like in this case, now this will become forward biased, and the current will flow like this. Again the potential of this point will be IR, because this point is 0, potential drop IR current, and this current will be governed by what is the potential difference applied between this point and this point. So it's like the circuit like this. So this is how it is actually. So the current will go like this, forward bias diode here, and so this is 0 volt, and this is high volt, and this is high volt, this is 0 volt, but this is reverse biased, so nothing goes here. What if we forward bias both of them? If we forward bias both of them, then the current will flow like this again, because of the current here. This will be at the higher potential, and when this is at high potential, again the output is high. So when this was 0 and this was high, which means 1, the output was high. And when both are high voltages, the output is also high voltage, which is 1. So this is what is OR gate realized using the diode. Then we have exactly the opposite kind of case in case of AND gate. So the output is taken across the same thing here, but instead of 5 volt, this is 0 volt, and these two are reversed now. So this is what is AND gate. Again we can have 4 conditions: 0 volt, 0 volt, 5 volt, 0 volt, 5 volt, 0 volt, 5 volt, 5 volt. You can figure out of your own also, and if you want I can explain it also. It's a very simple thing. Let's take the first case when both are 0. When both are 0 volts here and this is 5 volt, what will happen is, well, since this is high potential and this is low potential, which means the current can flow like this, and the diode will allow this current to flow. And when this diode will allow this current to flow, so there will be a potential drop across the resistor. So starting from 5 volt, there is a huge amount of potential drop. So almost entire potential drop goes here, and so across the resistor. So whatever high potential we started with, after losing the potential across the resistor, what we get is 0. Also you can say that these diodes are forward biased, and if there are ideal diodes, then there is no potential drop across them. So this 0 volt means this 0 volt, this 0 volt, this 0 volt. So 0 0 means 0. Okay, what if we put 5 volt here? Well, if we put 5 volt here, then 5 volt becomes unbiased, but this is 0 volt, so this becomes again forward bias. So again the current will flow, and if the current flows, see here we are having 5 volt, and let's say this is Vy. So what is the potential difference? 5 minus Vy. That's the potential difference, and that is equal to what? IR. So Vy is equal to 5 minus IR. So when is this Vy positive or high voltage? Only when the current is 0. And when the current is good, then this IR will cancel out this 5 and make the output voltage 0. So what if this is 0 and this is 5 volt? Again the current can flow like this, because this is forward bias, because this is low potential, high potential, high potential to low potential. This diode will allow the current to flow like this. So it's like a battery which is being connected like this here. So this current will flow like this, and this will go like this. So again all this negative terminal here, and this is like 0 volt, so this is also 0 volt. But what if both are 5 volt? If both are 5 volt, then this is unbiased and this is unbiased, so no current will flow. And if no current flows like this, because why should a current flow when there is no potential difference applied, isn't it? What is the potential difference applied across A and B? Well, this is also 5 and this is also 5. I mean A and let's say this point, 5 volt, 5 volt. Since there is no potential difference, difference applied across this, there won't be any current, because the current can flow only from high potential to low potential. So if no current flows, then there is no IR here. So if there is no current flow, no potential difference across resistor, so potential on both the sides are same, which means if this is 5 volt, this is also 5 volt. So only when both become high voltages, the output is high. So that's why this is a AND gate. Very simple. Now we can't make a NOT gate using only the diodes. You can think about it why. Moving on to making logic gates using transistors. Alright, so again the same logic here. A high voltage means 5 volt, 10 volt. See, it's not fixed rule that we have to use only 5 volt kind of thing. So see, there is always a range which is defined. For example, the high voltage can be considered from, let's say, 5 volt to 7 volt, and the low voltage is considered, let's say, from 0 to 2 volt. So if the output voltage is falling between 0 to 2, we can call it low, and if the output voltage is falling between 5 to 7, we can call it high. So we always need to define what are high and what are